Je vais vous introduire le talk donc, de Arthur et Eden sur Building an Entire CSP on Kubernetes, held together by Cloud Native Tech, YAML and Hope.
Hi, everyone. So this presentation is going to be in English. We're a bit short on time, so we'll skip the introductions. I'm Eden, if you haven't known already from the presentation.
And I'm Arthur, and we both work for a French cloud service provider called Agora Qualice.
And today we'll basically be talking to you about how we're building an entire CSP built on only Kubernetes, the cloud CNCF technologies, so cloud native tech, a lot of YAML, and a little bit of Hope. So how did we get here? Well, this project actually started back in 2023. Many of you are familiar with the situation. VMware was sold to Broadcom. Oops, thank you. VMware was sold to Broadcom, and the prices started rising. And with the prices rising, we decided we had to change course. We relied a lot on, as a company, a lot on third-party companies like VMware, whether it be Veeam or NetApp. And what was happening with VMware was basically our wake-up call. I think a lot of companies nowadays are trying to migrate away from closed-source companies into open-source technologies. And we thought that as a cloud service provider, we should be able to create our own platform using products that we use, we trust, and can contribute to. And that's basically how we started the project. We decided to call it Superphénix after the nuclear reactor. Well, it's kind of, for marketing, it's not a really good idea, considering it shut down. But yeah, we decided to call it Superphénix, or SPX for short. And it was basically 2 years ago that we started this project. And the idea was simple. Build an entire cloud service provider from the ground up without being tied to anyone else, using only our expertise.
So why did we choose Kubernetes? There are many alternatives to VMware. For example, OpenStack, Nutanix, Proxmox, to cite only a few. But we've been long-time users of Kubernetes at Agora, starting back in 2018. And we actually sell a lot of Kubernetes as a service. It is one of our most successful products. So we kind of became experts at it. And so we decided to build our new platform from scratch using Kubernetes at its core, without relying on any well-known solutions. It was a gamble, for sure, but if we succeeded, well, we would have a platform on which we can have complete autonomy and on which we can build anything. Also, our engineers, does it work? Well, yeah. Our engineers have a lot of experience with it, which means that onboarding them to our new platform would be extremely easy. And also, Kubernetes is extremely extensible. Initially, it only scheduled containers, but as you'll see in this presentation, we can use it to schedule VMs, to handle storage, and complex networks. So the reason we chose Kubernetes is because we have a lot of experience with it, and because we think it is so big, and the ecosystem around it is so big, that it is a project that cannot die. It is a strong, fully open source platform on which to build.
So, to be able to build our ultimate weapon, our ultimate platform, for any Yu-Gi-Oh fans, it's our Exodia. We basically need to be able to define our requirements. So, we're building a cloud service provider. That means we need to have customers to be able to log on to their platform on their own and administer their resources. So a secure admin platform is a no-brainer. And we also want them to have absolute autonomy. They can create their own resources, they can delete their own resources, modify them if needed. But absolute autonomy actually comes with automated billing, because they need to be built for what they actually create. And when we're talking about automated billing, we basically need to automate everything, whether it's resource creation, VM creation, complex networks, storage. And that was one of our big challenges. And finally, we needed to have an extensible platform. We could offer only the base features, but it would make no sense if we wanted to add features on top of it, like software as a service, platform as a service, for example, selling databases or Kubernetes clusters as a service.
So how exactly does Kubernetes address our requirements? Well, let's first talk about the centerpiece of it all that makes it possible for us to move from VMware to Kubernetes as an hypervisor. We need to transform Kubernetes from a container orchestrator into a VM orchestrator. And we use KubeVirt to do that. It is a plugin to Kubernetes that extends its API to not only provision containers, but also VMs based on QEMU and KVM, which are Linux technologies. So you may have seen a lot of conferences or talks or articles about moving from VMware onto Kubernetes and KubeVirt. And it is often presented as a very simple alternative, but is it as simple as that? Obviously, KubeVirt is only one of the elements that we need to build our CSP. We still need something to handle the network of the VMs. We still need something to handle the storage of the VMs. And this is often what you don't see when people are talking about moving from VMware to KubeVirt. And the reason is pretty simple. Not many people are actually doing it. They're writing articles, but not a lot of people do it. VMware can do storage using vSAN and network using NSX. How do we translate that on top of Kubernetes? To make things even more difficult, the networking and storage layers on Kubernetes are a lot different from what you'd expect from a standard hypervisor. For example, containers don't have stable IPs. You won't preempt these stable IPs. Containers cannot migrate from one node to another. You want your VMs to migrate from one node to another.
And well, after drawing some circles with KubeVirt, now is step 2, do everything else. And we searched for a long time and tested different ways to be able to handle networking and storage within SPX. We settled finally on using kubeOVN, which uses OVN and Open vSwitch. And for storage, we decided to use Rook, which deploys and uses Ceph to be able to handle block storage, file system, and S3. These two add-ons together, deployed on Kubernetes, basically extend its features to be able to orchestrate the networking and storage. But you might be asking yourself, okay, how do we actually talk to these different components? Well, since they're integrated into our Kubernetes clusters, they only need to talk through a single API, the Kubernetes API, which makes automation really easy. And if we ever need to switch components later on, we can do that pretty easily as well. You might not be familiar with kubeOVN, Rook, or Ceph, but rest assured they're actually battle-tested. For example, kubeOVN, which uses Open vSwitch, is actually the same technology used for OpenStack, which is used by CSPs. It's the backbone of CSPs like OVH, for example. Yeah. And then for Ceph, Scaleway and OVH actually use Ceph for their storage. You might ask yourself, okay, that's cool. What's different here? Well, the difference is that we're actually using Kubernetes to be able to handle all of these components. By removing as many different dependencies as possible, we're actually making it extremely easy to be able to handle the different containers, if you will, or the different bricks in your infrastructure onto, without actually needing to go to different tools.
So we now have the main ingredients to build our CSP. KubeVirt for the VMs, kubeOVN for the network, Rook and Ceph for the storage. But we still need a console, like the one provided by VMware, to get the real full self-service experience for our customers. And we built that in-house. We built a console on which our users can log in, create projects, create VMs, create networks, disks, order, Kubernetes clusters, anything you can think of. It's all API first. And if you know about Kubernetes, you probably know also about GitOps. We support GitOps, so our customers can write YAML files in Git repositories, and it gets synced onto the Superphénix platform.
Now, when we talk virtualization, as we said, we use KubeVirt to provision VMs. So for that, we're going to create Kubernetes clusters onto bare metal servers using Talos, the Talos Linux distribution. The installation and maintenance of the cluster is done using APIs, similar to the Kubernetes API. We install all of the components of the cluster using Argo CD, which is a deployment orchestrator, for those who don't know, and the installation takes about 5 minutes. We also peer our clusters together in different data centers to do disaster recovery for our customers in case of a major failure. All of our data centers are in France, so if the entire country of France gets detonated, then at that point, there's not much we can do. For our Ceph clusters, we do exactly the same thing. We're going to deploy Kubernetes cluster on bare metal servers, and then we're going to install the Rook Kubernetes plugin onto it. And then we are going to use the Kubernetes API to create Ceph pools for our installation clusters. Oh, virtualization clusters, sorry. We could also use Rook to run the on our hypervisors to run hyper-converged, sorry. But for performance reasons, actually, and because we use the storage clusters for our VMware clusters, we decided against it.
Now, for the network side, it was actually the most difficult one of the project. Kubernetes adopts a very simplified networking model. And what we need is an old-school model with switches and routers to emulate what you'd expect for VMs. And for that, we use KubeVN, which is a Kubernetes CNI, or a network plugin, if you wish, that gives the ability to connect our VMs using virtual or logical routers and switches, which we call VPCs and subnets. It also enforces firewall rules on the port of each VM, so we don't need a physical appliance. And it gives us the ability to even filter protocols that you normally wouldn't be able to filter with a standard firewall, for example, ARP. When it comes to connecting the VMs to the outside world, to the internet, we use NAT gateways and BGP. And actually, a lot of the code to make that work was written by ourselves, and we upstreamed it into KubeVN. Our network is extremely flexible, and users can configure everything by themselves. They can choose their own ranges, create their own firewalls, their own NAT rules, choose their IPs. Everything is self-service.
So we didn't have enough Exodia cards to actually, put all of the technologies together. We added a hoverboard at the bottom, just to be cool. Well, if our customers can create resources on the go, they also need to be built for it. And for that, we actually use our monitoring system. So if you use Kubernetes, then you know Prometheus. For those who don't know, it collects metrics on your cluster, and then you can use these metrics to raise alert when something is wrong. But with those same metrics, you can actually collect data points every single minute on our customers and the resources that they create. We can then compute the bill for those same resources and charge the customers accordingly. So if they decide to create and use a CPU and then create, use in VMs and then delete them, well, we'll know. Prometheus is actually extremely integrated into Kubernetes, which makes the deployment of that feature really easy.
Talking about features, we do not want to wait for an editor to bring us new features. We want to be able to build them ourselves. And nowadays, you can deploy almost anything on Kubernetes. And because Superphénix is based on Kubernetes, you can deploy almost anything on Superphénix. We are making sure that our project is easily extensible so that we can add new features and services for our customers. We've already seen that the development cost and time to build a new feature on top of Superphénix is significantly shorter than what we have on VMware. And this is due to the tight integration of the Kubernetes API. Using a single API, we can manage containers, services, VMs, networks, disks in a central interface. So instead of writing code to add new features, we can write Helm charts.
But is it really as easy as it looks? You know, take a bunch of open source projects, tie them all together, plop them all onto Kubernetes and say, hey, we're done. Well, the answer is unfortunately no. It actually took us nearly 2 years of development to get where we are today. Many of the features we needed didn't exist in the projects we were using, and we needed to implement them ourselves. We're simply doing something that wasn't done before, so everything is pretty new. We contributed to a dozen projects, including many of the CNCF ecosystem, which is the organization that oversees the development of Kubernetes. And we contributed so much, we actually became one of the maintainers of the KubeOVN project, which we're really proud of, by the way. So what does Superphénix support right now? Well, using GitOps or a web console, you can create VMs, disks, complex networks, or Kubernetes clusters as a service. What do we plan for the future? Well, more services. Whether it be more SaaS, we want database as a service, GPU as a service, containers, etc. Anything you want as a service. But it's important to add as a service at the end.
So during this project, we got more and more convinced that open source software was the right path for us to take. It gave us faith that we could rely on solid projects, open source projects with no monopoly. And it also gave us faith that we could build our own CSP, contributing along the way to a lot of projects. The question is Superphénix open source in itself? The answer is that it isn't right now, but our plan is to make it fully open source in 2026. We want this project to grow beyond Agora. We are planning on slowly rolling out Superphénix for our customers at the beginning of 2026, but we believe that there's other people out there that may benefit from the work we've done. Superphénix is a tool for you to host your VMs, your network, your storage, and any service you can think of. And it's all based on one of the biggest open source projects out there, which is Kubernetes.
Thank you for listening. If you have any questions, now's the time. We answer both in French and English. And if you're interested in knowing more about Superphénix, you can scan this QR. Well, you can see us at the booth. We're on 1C43 level -1. It's a bit far. It's right next to the popcorn machine. Well, on top of the popcorn machine, so you'll get the smell of butter, which is pretty cool. And if you want to know more about Superphénix in general, you can scan this QR code and actually sign up to our newsletter, where we'll publish updates about how it's going, how it's developing, and when it goes open source. Thank you.
Si vous avez des questions, n'hésitez pas. Je peux vous passer le micro. Français ou anglais. As you wish.
En français, du coup. Pourquoi ne pas avoir utilisé Longboard par rapport à Ceph?
Plusieurs raisons. On a envie d'utiliser le stockage aussi en dehors de Superphénix. C'est-à-dire que c'est du stockage qui va être utilisé principalement aujourd'hui pour des VM qui tournent sur Superphénix, mais on a aussi un existant qui est sur VMware. Il est beaucoup plus simple en fait d'utiliser une technologie comme Ceph pour la partager là-bas. Également, Ceph supporte beaucoup de protocoles différents. On peut faire dessus non pas seulement du bloc pour de la VM, mais aussi du S3 ou du file system, NFS, FFS. C'est une technologie qui est éprouvée pour un CSP, donc c'est celle qui correspond le mieux à nos usages. Quand on est en mode hyper convergé, effectivement, par contre, ça peut être un peu lourd. Et à ça, on réfléchit à des alternatives pour pouvoir avoir plusieurs CSI différentes.
Superphénix est basé là sur les machines là, sur Talos. Quand on instancie nos propres clusters Kubernetes, ils sont montés eux-mêmes sur des VM qui sont gérés par Superphénix, ou c'est, je n'ai pas bien compris en fait.
C'est ça.
C'est ça. Donc on instancie d'abord les VM qui sont gérés par Superphénix et après on met les clusters, nos propres clusters Kubernetes dessus.
Alors vous pouvez faire comme ça. mettre des VM et puis installer vous-même le Kubernetes dessus, mais on a du Kubernetes intégré, ce qu'on appelle du Kubernetes as a service, où les VM vont se créer avec l'installation de Kubernetes qui se fait en automatique. Et le cycle de vie du Kubernetes aussi en automatique. Donc pour ça, en fait, on utilise la cluster API, et ça permet depuis la console du coup, de cliquer sur le nombre de nœuds que vous voulez mettre, la version du Kubernetes, les réseaux que vous voulez mettre dedans, quels IP publics vous pouvez utiliser. Vous avez vraiment toute une intégration avec la partie IaaS, mais ça c'est ce qu'on appelle du PaaS, du Platform as a Service. Mais on peut aussi installer son cluster nous-mêmes, hein. C'est pas un problème. Mais bon, on donne les outils pour le faire, donc ça fait moins de travail.
D'accord, mais le principe c'est que si je crée un cluster Kubernetes, il est basé sur les VM.
Il est sur des VM qui tournent sur lui-même un cluster Kubernetes. Ouais.
Okay,
c'est un cluster Kubernetes sur un cluster Kubernetes.
Merci beaucoup.